Hello viewers, I'm Keerti Bhave. Welcome to this session on Arrhenius' theory of ionization. After viewing this video, you will be able to understand the process of ionization, state postulates of Arrhenius' theory, and understand behavior of an electrolyte when dissolved in water. According to the Arrhenius theory of ionization, electrolytes contain electrically charged particles called ions. These charges are positive for hydrogen ion or ions derived from metals and negative for the ions derived from non-metals. For example, if you dissolve sodium chloride in water, in the aqueous solution you have sodium ions coming from the metallic sodium and you have the chloride ions coming from the non-metallic chlorine of the sodium chloride molecule. Similarly, if you dissolve copper sulfate in water, in the solution of copper sulfate, you have copper ions coming from the metallic copper of copper sulfate, while the sulfate ions come from the non-metallic part of the molecule. Likewise, if we dissolve magnesium nitrate in water, which contains magnesium ions and nitrate ions, magnesium ions come from the metallic part of the molecule, while the nitrate ions come from the non-metallic part of the molecule. The number of electrical charges carried by an ion is equal to the valency of corresponding atom. When we dissolve sodium chloride in water, in the aqueous solution of sodium chloride, you have sodium ions with a unit positive charge because the valency of sodium is +1, while you have the chloride ions with a charge of -1 because the valency of chlorine is -1. For copper sulfate, the copper ions have +2 charges because the valency of cupric ions is +2, while the sulfate ions have a charge of -2 because its valency is -2. In case of magnesium nitrate, the magnesium ions have a charge of +2 because magnesium is a bivalent atom, while nitrate has a charge of -1 as the valency of nitrate is -1. Molecules of electrolytes, acids, bases and salts dissociate into oppositely charged ions on dissolution in water. Here we can see sodium chloride which is dissolved in water. In the crystalline form, the sodium ions and chloride ions are closely packed together. When they dissolve in water, they dissociate, giving you sodium ions and chloride ions. So in a solution of sodium chloride, you do not have molecules of sodium chloride and molecules of water, but you have sodium ions, chloride ions and water molecules as seen in the picture. The number of positive and negative charges on the ions must be equal so that the solution as a whole remains neutral. Sodium chloride when dissolved in water gives sodium ions and chloride ions. Sodium ions have a charge of +1. Chloride ions have a charge of -1. The net charge is 0 and hence the solution is neutral. If you have a solution of copper sulfate, the copper ions have a charge of +2. The sulfate ions have a charge of -2. The net charge is 0 and the solution is neutral. Similarly, for magnesium nitrate, which ionizes to give you magnesium ions having a charge of +2, and you have nitrate ion having a charge of -1, but you have two such nitrate ions which gives you two negative charges, and therefore the solution is neutral. In a solution, the ions are in a state of disorderly or random motion. Upon colliding, they may combine to give unionized molecules. Ionization, therefore, is a reversible process in which the solution contains ions of electrolyte together with the unionized molecules. Here we can see copper sulfate, which when dissolved in water gives you copper ions and sulfate ions. Few of the copper ions and sulfate ions combine or associate to give back copper sulfate. So in the solution of copper sulfate, you have copper ions, sulfate ions, and few molecules of copper sulfate. I hope you have understood the concept of ionization. Wish you happy learning. Thank you.